discussing vertical integration, in particular, the question, what should Tesla do and what should they not do? And from the perspective of vertical integration and from the perspective of long-term wealth creation. What do I mean with that? A company like Tesla is disruptive in the true sense of introducing fundamentally new engineering practices and ideas to the world. So whether that is electric cars, autonomy, solar powered cars, mega packs that can store energy, there's a lot of vectors that a company like Tesla is attacking. And the question arises naturally, well, which of those should they do? Which of those should they outsource? Just as an example, we believe as customers and investors that making tires would be useful for Tesla the same way they're making seats. Why? Because seats are important. It's the comfort, it's the way you feel in a car. It gives you a comfort that you're buying a quality car if the seat is comfortable. And that's probably partly why Tesla is investing in seats. Tesla is as far as I know, at least very involved in the sound system that they have, because obviously that's important. So in that sense, making tires would be very useful. And I'm going to get to that a bit later within the context of a longevity of the car. The way we see the Tesla car business is it's very intertwined with the Tesla AI business, because autonomy will drive usage and adoption will drive down cost per mile or cost per minute, and that is eventually going to decide whether Tesla or the Tesla ecosystem will win against other ecosystems, in particular the status quo with ICE cars. What do we mean with that? In the long term, we believe Tesla has a chance to change the transportation and energy industry through the beachhead of transport by introducing an electric car and then adding autonomy to the car and making the car drive at least 5x more than a regular car. So we go from 100,000 to 500,000 miles, which will lower the cost per mile and cost per minute that people are paying to be driving around. That will increase the usage of driving, and it will make Tesla a winner in the marketplace, like AWS, Microsoft, or Apple. They will become a trillion-dollar company, because they have a much lower cost solution to a problem that everybody has. In this case, it's transport, but it's very closely tied to energy, of course, because when you have a large when you have a car that drives 5x more, you also want to make sure that the cost of energy is lower, and that would excuse me, that was just a motorcycle very close to the car, so the car got scared. I'm on FSD, just as a note. So let's go on. So we believe that the question of vertical integration comes up, and I want to tie it to a presentation that I attended recently, which is a presentation by a lady, a professor from UT Austin, and she does recovery of rare earth metals from coal ash. So this might sound like a small niche problem that shouldn't be discussed in the grand scheme of disruption and AI and electric cars, but actually it's not such a small problem, because rare earth metals are absolutely key to the future of a decarbonized energy infrastructure. We're already large consumers of rare earth metals through the smartphone infrastructure, and the electric car / AI autonomy will bring even more, and then we add robots to that, meaning humanoid robots. So having rare earth metals in all kinds of devices will become second nature. Therefore, the recovery of rare earth metals from coal ash actually turns out to be a lot more important than it might sound in the first place. What this lady was discussing, she is part of the environmental engineering department of UT Austin. She has a PhD in environmental engineering. And that in itself is an interesting topic because it just raises a field to my attention that I haven't been paying attention to much. And that is that you can actually innovate in mining and environmental engineering, which is what it is actually. It's think about it like technology applied to mining. And there's a lot of interesting problems to be solved that could be crucial for the long-term longevity of a modern decarbonized energy infrastructure. Uh, the reason I find that so interesting is because we often get boggled down in, let's say the big picture headline grabbing. Is Tesla winning, or is BYD winning, or the legacy automakers winning? And then we forget sometimes that to win, it takes work, and work has to be done across the value chain. And therefore, the question of vertical integration is key. This is not in our podcast. It's April 27, 2024. This is Grim Delco. It's a weekend. There's no update for the year. We are down 20.2%. The market's up 7%. We're outperforming by 27.2%. So let's talk about vertical integration from the perspective of Tesla and ask a few fundamental questions. In particular, when should Tesla be involved and when should they outsource? And I want to take two examples here. One is the rare earth metal example, and then the other is AI training. Let's start with rare earth metals. So this lady, I put the names in the show note. She's a professor at UT Austin in environmental engineering, and she found a very interesting technology or a technique to extract rare earth metals from coal ash. And what it takes to do that is actually simulation. What she does is she takes a picture of the microporous structure of stone. In this case, it's coal ash, but we can generalize it. Just think about generally the problem here. Okay, you have a solid material, rock, or something silicony or rocky or whatever it is, and you want to extract metals or chemicals or substances that are trapped in this material. So this is the goal. This is what 99% of mining actually is, right? How do we get desirable substances out of a bigger substance, and typically rock or earth, something we find in the earth? How do we extract that? And the way this lady is approaching the problem, she's saying, let me take a picture of the porous structure of the substance that I'm looking at, and then try to estimate the dynamics, the fluid dynamics, the fluid to fluid, fluid to solid dynamics that are in place, and then find optimal extraction techniques, whether it's using gravity, using chemical energy, i.e., acid or high acid, low acid type substances to leach the desired substance out of the rock. So those are the kinds of work that are done. Now, this is kind of where I want to stop in terms of the weeds of technology. I don't understand exactly how the microporous structure really influences fluid to fluid and fluid to solid dynamics. But let's leave it at I understand that those dynamics matter and that understanding the spatial structure of a substance helps in designing technologies, techniques to extract substances. So that's what this lady does. She builds silicon-based models that mimic the porous structure of the actual substance. And then she runs experiments to see, okay, if we use this type of chemistry versus that type of chemistry, or this type of centrifugal or that type of centrifugal. There's lots of different technologies to extract rare earth metals from coal ash. Now, how did she get to coal ash? It turns out that coal ash has quite a bit of rare earth metals. The advantage of coal ash is also that it's already burned down substance, right? We burn the coal, so we extract energy, or we add energy to the substance because we wanna gain thermal energy. But as a side product, we're left with ash, which is a very which is a very highly concentrated rest product that actually turns out to have a lot of rare earth metals in it relative to the rest of the substance. So we could then look at this and extract the rare earth metals. So this is kind of the project, right? Now, in the grand scheme of things, why is this important? Like I said in the prelude, rare earth metals are key to the electronic and decarbonized energy infrastructure of the future. They're key in computation, and they're also key in electric cars, which in general are just computers on wheels. So the more we have of it, the better. We can build just one use case is we can build permanent magnets or inductive magnets. Doesn't matter exactly what kind of magnets we're using, but the more rare earth metals we add, the easier the transfer of chemical energy to kinetic energy is, and therefore we can have more efficient electric cars. So this is one use case. They're also used in the iPhone type infrastructure, so compute, edge compute, Internet of Things, any of the big technology drivers of the first part of the 21st century are substantially driven by rare earth metals. The way rare earth metals are mined today is just let's say environmentally not acceptable, and to some extent there's also environmental hypocrisy at place here. So we have the largest rare earth mine in the world in California closed because of environmental consideration, and all we're doing now is buy the stuff from China because over there we don't have those environmental considerations. So that's what I call environmental hypocrisy. Now, as far as Tesla is concerned, the question here comes up, well, how much of that should they be involved in and how much should they outsource? And I think like most of businesses that Tesla is involved in, it typically starts with, okay, look, if it's good enough from the outside, we want the outside to do it, unless it's core to our business, such as the battery, the powertrain, the design, and the AI. Now, even with the battery, the question now is coming up with Rubalino leaving and Musk now in China. There's definitely a chance. I wouldn't be shocked if we heard much larger supply contracts between CATL or other Asia-based battery manufacturers and China and Tesla. In other words, it looks like Tesla is kind of giving up on that part of the value chain because it looks like the others are good enough. And that, to me, is usually the driver of any kind of disruptive company like Tesla. I mean, you could say the same thing about Amazon, Microsoft, Apple. That when companies like that start penetrating markets, they actually would like to delegate as much as they can. And the problem is that often they can't because the productivity of the supply chain doesn't match theirs. And whenever the productivity of the supply chain doesn't match theirs, they have to take over. But when the productivity does match theirs, usually it's okay for them to give up that part of the value chain. Now, of course, you want to make sure that you keep something and you don't get disrupted totally, and that's part of the existence of a company. But in this case, again, rare earth metal extraction, in my opinion, is still a very nascent industry, and therefore there could be a need for Tesla to get involved, which I happen to know they are, at least through grants and know-how transfer from the academia. Whether they will actually commercially start doing this like they're doing with lithium-ion processing, we're not sure. But the question arises again. It's about productivity. In other words, if we have a value chain that is good enough, they bring the best employees together. They have good leadership, good return on capital, large iterative turnout of new technologies and all that, then Tesla doesn't really have to be involved in it. The second example I want to use in this vertical integration conversation is the question of AI. And it comes up because Tesla, of course, is highly compute and memory intensive with the AI that they're building around FSD. And if we want to have a long-term autonomous driving infrastructure, we have to assume that there's going to be tens and tens of billions of dollars invested in AI infrastructure. So then the question naturally comes up, well, should Tesla actually be involved in that particular part of the value chain? And the answer to that question is yes and no. Yes, because again, if your supply chain is not productive enough, you should take over. So, for example, the inference engine seems to be part of Tesla's core competency, partly because, like Musk said, we didn't have a choice. Nobody had a problem like Tesla to solve massive compute in an edge device with a decent amount of energy supply, but not enough to drain the battery all the time. So that's the problem that they solved with the inference engine in the car. On the training side, it looks like there's a chance that that is taken over by Nvidia and others, and that Dojo, which was supposed to be sort of the solution, the Tesla solution to the training problem, that maybe Dojo is not productive enough to replace other parts of the value chain. In other words, Dojo or the training might or might not be necessary to be integrated into Tesla. That's a big question. I think the conversation is ongoing. Now, the way we see it at Orange Capital Partners is the following. The problem with training AI, modern AI training technology, is to exploit two things. One is parallelism, and the other is sparsity. Those are the two vectors on which Nvidia has been innovating relentlessly. With parallelism, I mean data parallelism, model parallelism, and other parallelisms. Jensen talked about this at GTC. So if you can, you have a model, large, parameter parallelism. The question is always the same. Okay, how much of this workload can we do simultaneously, and how much has to be done sequentially? And what NVIDIA is doing extremely well, it helps developers solve that problem by relatively simple delegation mechanisms through CUDA and others, but CUDA is the main one, where they can program, let's say, build a GPT-5 and or Claude or Mixtral or mixture of experts, all these kinds of ideas that are floating around in the AI space. They're all again converge to, okay, look, we have a massive model, but can we parallelize something? For example, mixture of experts would suggest that we can train a model by using different parts of the model simultaneously, because some data has to be trained here and some data can be trained there, and they don't have to wait for each other. So that would be maybe expert parallelism or model parallelism. But the flexibility that NVIDIA offers in solving some of the questions about parallelism, in our opinion, is half of the reason why NVIDIA is so successful. The other half of the reason is sparsity. This is according to the chief science officer of NVIDIA. The name eludes me right now. He gave a presentation at Micro, I think about a year ago, where he spoke about this. I'll put the slide in the show notes. And there, he specifically says that the most important part of the advancements of NVIDIA relative to Moore's law come from sparsity. In other words, NVIDIA found out ways to take advantage of zeros in matrices and therefore make matrix multiplication a lot more efficient, and find out, okay, in a nutshell, if you think about the AI problem from a different perspective, what is the AI problem from a technical perspective? It's about matrix multiplication. And matrix multiplication, once you go in higher dimensions of matrices, becomes very quickly, energy and compute prohibitive, also memory prohibitive. So one of the problems that NVIDIA solved is, okay, how can we have a matrix multiplication and store the results on chip in high bandwidth memory, so we don't have to move those results always back and forth, and then we can just bring in new data to update the weights and so on and so forth. Now, this can be done, again, through model parallelism, data parallelism, and other parallelisms, but also, very interestingly, it can be done more efficiently if we can reduce the dimensionality by taking advantage of sparsity, or in other words, compression, right? Can we take the input data and compress it to the point, think about like a zip file, where we don't actually have to do the matrix multiplication on the whole thing. We can zero out a lot, but quantize the model and just take some data points that are key, find out maybe statistically or randomly or heuristically
which data points are important. So those are the kinds of things that Nvidia has been working on. Why am I talking about all this? Well, these are things that Dojo seems to be not very good at. I think the way I understand Dojo is Dojo was built for convolutional neural nets. And the way typically a hardware initiative works like that is that you build the hardware and then you have a compiler that is kind of more like a conveyor belt. It's just says, look, the hardware is doing, you know, let's use an analogy. It's doing stamping. So any material that needs to be stamped goes left. Any material that doesn't need to be stamped goes right. And over there, it gets, some other stuff. So there's some crude things that happen with the input data, and the compiler, moves these things more like a, transactional sort of gating function, and maybe process data a little bit, and then, it goes from input to output. And that is very efficient if that's the only thing you do. But it becomes very cumbersome if you keep changing your architecture on top, or even more importantly, if you want to iterate on exactly those types of things like I discussed before, let's say model parallelism, or even iterate on models itself. You need to have a little bit more flexibility, and that's what most of these dedicated hardware mechanisms, whether it's Dojo or the TPU at Google, or the Meta or the Amazon, the Microsoft hardware initiatives, they all suffer from the same problem. So that's why we believe Tesla has decided to maybe step back a little bit on the training side and double down on Nvidia. Now, long term, it might still be useful for Tesla to actually build an integrated AI training infrastructure business. But like many things, this requires a little bit more than just hiring, disgruntled AMD employees or Intel employees, or maybe even Nvidia employees. That's the problem. Like, if you want to be good at this, you got to go and get the top talent. And you're not really disrupting anything right now, so it's going to be difficult to build it from scratch, and it's going to be very hard to hire the best talent from the best company, which right now is Nvidia. So the solution then is, one of them will be, of course, a combination between Nvidia and Tesla, but that's for another episode. So right now, where Tesla stands is, we believe that the best course of action actually is to double down on Nvidia, which is what they're doing. And then maybe long term, think about building out an infrastructure that has CUDA type flexibility and that can handle massive amounts of multimodal parallelism, because that is really where Tesla is going to play most of its AI infrastructure have to play for most of its AI infrastructure needs. It's about parallelism. It's about multimodal parallelism. It's about applying multimodal data to robotics. It's about understanding physics. It's about solving the 2D to 3D problem. Those are new problems, and that's an opportunity for Tesla. But right now, again, just for the self-drive, it's probably okay to stick with Nvidia, but maybe for the multimodal robotic training, we could see more, proprietary vertical integration. Lastly, I want to say also, I've been pounding this the semantic map thing. I believe that that's something that Tesla should be also investing in, because that's, Google Maps are not good enough for autonomous cars. They're good to tell a car where to go, but they're not very good in telling the car what exactly is going on. Let's say where you're picking up your child, and it takes you to the school, but it doesn't understand that on the left side there's a couple of children playing, on the right side there's a dog on leash jumping around. Like, those are semantic things that the robot needs to understand to be safer and to have a better understanding of the environment. We believe that there is actually enough technology available for this. Large language models offer a semantic understanding. Visual language model offer a translation from vision to semantic understanding. So there's a lot of applications along those lines, and that's something where we believe Tesla should be also investing in. So to summarize, the three things where we see vertical integration, questions of vertical integration. One is mining, in particular rare earth metal extraction, very important for a future of autonomous electric cars. We see the training AI for now as NVIDIA driven, but long term there's still room for vertical integration, in particular when it comes to multimodal training. And then also semantic maps, understanding the environment beyond just localization. Those are areas where vertical integration would be great if Tesla did it. Thank you.